Good day everyone! Welcome to Sir Fox Learning Channel once again. For today's video, pag-uusapan po natin relationship of pressure, area, and volume. So pag-uusapan din po natin ang relationship ng pressure, depth, and density. Kung gusto mong malaman, ano nga ba yung relationships ng mga quantities na ito, well, spend time, panoorin mo ang video ito. At kung bago ka sa channel na ito, huwag mo sanang kalimutang mag-subscribe at i-hit ang notification bell all para maging updated ka sa mga susunod ko pong video lesson. Happy learning, everyone! We are done with relating the density, specific gravity, mass, and volume to each other with our discussion about fluid mechanics. At this point, we will discuss the relationship of pressure to area and force, and the relationship of pressure to fluid density and depth. We all know that the molecules in a fluid are free to wander around. So, if you can still remember the phases of matter, solid, liquid, and gas, every molecule of these phases are freely to wander around. In their wanderings, they sometimes collide with the sides of their container. So as the molecules of fluid, since we are talking about fluid, of its wandering, it sometimes collide to the container, to the side of their container, kung ano man yung container na kinalalagyan nitong fluid. The more the molecules collide with the walls, the more force it felt or is felt. Kapag maraming collision yung nangyayari sa walls, mas maraming forces yung nararamdaman. Mathematically, pressure is defined as the force per unit area. With this expression, P is equals to F over A, where P is the pressure, F is a force perpendicular to surface, and A is the area. If you will notice here, the relationship of force, pressure, and area, pressure is directly proportional to force and inversely proportional to area. Ang sabi kanina dun sa ating statement, kapag maraming collision yung nangyayari, mas maraming forces yung nararamdaman. Ibig sabihin, there is a tendency of high pressure inside. So we will notice here that pressure is directly proportional to force. Ibig sabihin, as the force increases, the pressure as well increases. Or as the force increases, or as the pressure increases, the force as well is increases. But inverse to area. Kapag ang area in-increase mo, probably the pressure will decrease. Pero pag din-increase mo yung area, probably the pressure will increase. Kasi inverse yung kanilang relationship. And pressure is measured by Pascal or Newton meter squared. For every 1 Newton meter squared is equals to 1 Pascal. But then, 1 Pascal is very slow. That's why mostly ang ginagamit is kilopascal or atmosphere. In a fluid, the pressure is exerted perpendicularly to all surfaces. Katulad po nung illustration po dito sa picture na ito. The pressure is exerted perpendicularly to all surfaces. So as the arrow pointing out to the walls of the surface. Static fluid cannot produce a force parallel to a surface since it is not moving parallel to surface. Pag sinabi po nating static fluid, it is a hydrostatic or a branch of fluid mechanics that studies the condition of equilibrium of a floating body and submerged body. Fluids at hydrostatic equilibrium and pressure in a fluid or exerted by a fluid on an immersed body. So, for instance, you are drinking a juice box. In the process, of course, you will suck all the juice and air out of the box. The top of the box is 7.5 centimeters by 5 centimeters. If the air pressure is 1.013 times 10 to the power of 5 Pascal, how much force is acting on the top of the box? So, to determine the force that acts on the box, on the top of the box, we just simply use the mathematical expression of pressure, which is force per unit area. The unit of the box or the area of the box is length times width, yung area ng box. So we will multiply 7.5 times 5 cm, and that is equal to 7.5 times 5 cm, 7.5 times 5 equals 37.5. We will convert 37.5 to meters squared since 1 Pascal is equals to, yung definition natin kanina, 1 Pascal is equals to 1 Newton meter. So for us to cancel out the unit measure here, or to arrive the unit measure of force, we need to convert 37.5. Once you multiply 7.5 centimeter times 5 centimeter, that is 37.5 centimeter squared. So, pag dinerive po natin yung 37.5 centimeters squared to meters squared, for every 100 or 1 meter, you have 100 centimeter. So, 37 divided by 100. 37.5 divided 100 is equal to 0.037 meters squared. So this is now your area. So pag ang hinahanap kasi natin is force. So force is equal to pressure times area. Ang pressure po natin is 1.013 times 10 to the power 5 pascals times the converted area 0.00375, that is equal to 379.875 newtons. So we convert 7.5 and 5 cm to square meter, and therefore you have 0.00375 times your pressure 1.013 times 10 to the power of 5 pascals, and you will have a force of 379.875 newtons. This is your force of sucking the juice and air out of the box. Now, would the force of the side of the box be more or less than the top? Probably more, because more area. There's a greater area. The force that squashes the juice box is from the weight of all the air above it. Remember that in atmospheric pressure at sea level, for every 1.013 times 10 to the power of 5 Pascal is equal to 1 atmosphere. The column of static fluid experiences several vertical forces. Since the fluid is not moving, it is equilibrium, and therefore the forces, the summation of forces is equal to 0. If the summation of forces is equal to 0, therefore the summation of force is equals to pressure, the first pressure times the area minus the second pressure times the area minus the first pressure times area, minus mass times acceleration due to gravity is equal to 0. Therefore, your second pressure times the area is equal to the first pressure times area plus mass times acceleration due to gravity. Now, since we cannot measure the mass of a fluid, therefore, isa-substitute po natin itong mass ng value niya taken from the mathematical expression of the density. Diba? Density is equal to mass over volume. If we will get the mass here, your mass here from the density is density times volume. Therefore, your pressure sub 2 times the area is equals to pressure sub 1 times area plus the density, copied this, times volume times acceleration due to gravity. Now, since ang volume po natin dito, ang pinag-usapan po natin na volume is equals to the area times the height. So therefore, your P sub 2 times A is equals to P sub 1 times A plus density times acceleration due to gravity, tapos yung value ng V na AH. Now, for us to determine the value of P sub 2, the pressure in P sub 2 here, we will just divide both sides by A. Therefore, you will now have P sub 2 is equals to P sub 1 plus density times G, or acceleration due to gravity, times height. Our P here is the pressure due to the fluid at depth, H, kaya may H kasi because of the depth, below the surface. If the pressure is known at a depth, the pressure lower down can be found by adding density times acceleration due to gravity times height. Kapag ang pressure is known at a depth. So you will just use density times acceleration due to gravity times height. This assumes that the density is constant with depth. Though this is good estimate for liquids, but not for gases unless yung height or H is small. Now, would Hoover Dam need to be just as strong if the entire lake behind the dam was reduced to an inch of water behind the dam, but same depth as the lake? Probably yes. The pressure depends only on the depth. Okay, so much for that, for pressure and depth. And hopefully, this simple presentation ay nakatulong po sa inyo. Kung bago ka sa channel na ito, sana wag mong kalimutang mag-subscribe at itang notification bell on para maging updated ka sa mga susunod ko pong video lessons. Happy learning, everyone!